I do welcome you again to the conversation, just as promised, in business math and statistics. We are looking at question number 4 and 5 of the assignment. So let's start with question number 4, and from there we'll see if we can have time to do as well question number 5. It is important for it's very important for me to report that even tomorrow we are expected to meet for business math and the statistics. Ideally by Wednesday we should be done so that we can have enough time to type your work. Can you see the screen and can you hear me clearly as I start doing the questions together with you? Can you see the screen? Can you hear me? Oh. Hello, Mr. Boniface. Are you able to hear me? Can you see the screen? Please respond. People are logged out, obviously, because of the network.
Yes, I can get you on my end. I can also see the screen.
All right, thanks for that feedback. Question number 4 is reading, and as I read in your hearing, that Joseph and Joyce scored the following marks from the 10 sample at the end of semester business math in the statistics test. The tests were marked out of 15. So these people, they had their results. You have the results for Joseph. You also have results for Joyce. The required is to calculate the coefficient of variation for each of the set of tests. Okay, the set of the test for for Joseph and for Joyce, and we check whose performance was consistent, and we got to justify why we say that. Now listen, we are just required to do the coefficient of variation. It is important to score that the coefficient of variation is given as the standard deviation divided by the mean. Okay, basically the standard deviation divided by the mean times 100. That gives us the coefficient of variation. You and I know that you cannot find the standard deviation before you find the mean, right? Because you need to use the mean to find the standard deviation. It follows that you have to start by finding the mean, all right? Then do the standard deviation, then find the coefficient of variation and pass a comment. Okay, let's go. We need to find the mean. We'll start with Joseph. How do we find the mean from what we said yesterday? You have just to consolidate all these and divide by how many they are. There are how many? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tests. So for Joseph, we shall say 35 plus 26 plus 41 plus 38 plus 36, plus 48 plus 37 plus 30 plus 35 and plus 24. And all that to be divided by 10, it should give us the mean X bar. Are we good? I guess we are good up to there. You can do the quick math and find the mean. Do the calculations quickly, add those, consolidate them, and then from the consolidation, you should be fine. 35, 24. And if you have done the right thing, you should be able to find on top, you should be able to find 350 divided by 10. That should give you 35 as the mean for Joseph. Okay? So the mean for Joseph is 35, isn't it? 35. Okay?
Yes, sir.
What do we need next? The standard deviation. Now, I told you that to find the standard deviation, the formula that we use is standard deviation is equal to the square root of the summation of the deviation, that is x minus x bar for the mean, squared divided by n minus 1. n minus 1, of which our n is the total sample. That's basically the total sample of the tests. The tests are 10, so we say 10 minus 1, which shall be 9. So our x is representing the individual score. So for Joseph, we'll have 35 minus the mean, 35. You square that plus C. What's the next score? 26, isn't it? 26 minus the bar. The mean is 35, we said. You square that plus C what? 41 minus 35. And you square root that plus C. What else? 38 minus 35. You square root that plus C. From 38, we have 36 minus 35. You square root that plus 48 minus 35. You square root that plus 37 minus 35. You square that plus what? Plus 30 minus 35. You square that plus 35 minus 35. You square root that plus 24, the last one, minus 35. You square root that divided by n minus 1, which is basically 9. It will be 9. Our n is 10. There are 10 sample tests. So whatever you find on top divided by 9, then you square root it. That will give you the standard deviation. Okay? I guess you're following up to there. This is basically the same stuff that you were doing yesterday. So what do? You can deal with them one by one if you don't want to make a mistake. You say 35 minus 35 squared, that will be 0, right? That will be 0 plus 26 minus 35. Then you square that, that should give you 18. That should give you 81 actually, because that will be 9. 26 minus 35. 26 minus 35 should give us 9, yeah? 9 squared is 81. Plus 41 minus 35. It is basically
6.
This is 6. Square that. 36.
Yes.
And then you have 38 minus 35. That is 3. 3 squared is 9. I guess you're following what you're doing. I'm not even using a calculator. Plus, what is this? 36 minus 35 is 1. 1 squared is 1. Right? 48 minus 35 is what? Is 13, yeah? 13 squared is 169.
Yes.
Plus 35 minus 37 is 2. 2 squared is 4. Plus 30 minus 35 is negative 5 squared, which is giving us 25. Plus 35 minus 35 is 0. Plus 24 minus 35. Okay. 11 squared, 121. Right. So that's what you find on top, divided by 9. That is if you are finding it challenging to deal with them at once, okay? And I think this way will help you not to make mistakes, because many people make mistakes. These numbers are just too many to deal with. When you do your right computations on top, is just basically adding. You should find 446 divided by 9. What is 446 divided by 9? And you square that. Please, what do you find? 446 divided by 9. What do you find? We can do that quickly. Hello, 446 divided by 9. What do you find?
It gives us 49.55. There's a recurring 5. What about 2, 3, 4, 5, 6, 7, 8, 9? 10 of them. 49 point. then the 5s, 10 of them.
Oh yeah, which is approximately 50.
Yes.
Okay. What is the square root of that? That will be the standard deviation.
It will be 7.0395.
Right. 7.0395, we can just say 0.4. That is the standard deviation. Is that hard? No, sir. Then the coefficient of variation for Joseph shall be easy, right? Because I said it's the standard deviation divided by what? Standard
Sir,
deviation divided ma.
sorry, take you back. Where did the 9 came from?
Or the formula is standard deviation is summation of x minus x bar squared divided by n minus 1. Our sample size is 10. N is sample size.
Yes. All right.
Sharp
Thank
girl.
you.
You're welcome. And then from there, you shall have 35 times 100. What do you find? 7 over 35 times 100. What do you find? What's the coefficient of variation? We need to do this quickly. For Joseph.
7.04 over 35 times 100. That's 20.11428.
20.114.
114287571.
So this is a percentage, which is approximately 20%. This is approximately 20%, the coefficient of variation, right?
Yes.
Okay. Let's go to the one for Joyce. Before we pass comments, we have to go for Joyce as well. We start with the mean as well. The mean is summation of all the scores divided by n. So you say 24 plus 28, 24 plus 21 plus 27 plus 26 plus 24 plus 28 plus 22 plus what? 23. You're following, eh? For Joyce, divided by 10.
Yes,
If
we are
you do
following.
the right thing, if you do the right top, you should find 247 to be divided by 10 so that you can find 24.7 as the mean. Okay, 24.7. If you have the mean 24.7, then you could go ahead and find the standard deviation, isn't it? How do you find the standard deviation? Standard deviation is easy to find from here. I told you the formula is given as square root of the summation of the deviations. The scores minus the mean of them, square that divided by n minus 1. Remember? So let's work out the top part. We find the summation of the deviations, isn't it? We do the same thing you did to Joseph. You say 24 minus 24.7, which is the square root, plus 28 minus the mean, you square that, plus another 24 minus 24.7, you square that, plus 21 minus 24.7, you square that, plus what? 27 minus 24.7, you square that, plus 26, eh? 26 minus
Yes.
24.7, you square that, plus 24 minus 24.7, you square that, plus 28 minus 24.7, you square all that, plus 22 minus 24.7, square all that, and finally 23 minus 24.7, you square root that and divide by 9. You get it, right? You know where 9 is coming from. So let's say sample size minus 1.
Yes.
Now, if you have done the right work on top, you can deal with them one by one if you are interested. If you are interested, 24 minus 24.7 squared should give you 0.49. Plus 28 minus 24.7 squared should give you 10.89. Counter check. This one will repeat, give us 0.49. Plus 21 minus 24.7 squared gives us 13.69. Plus 27 minus 24 gives us 5.29. Plus 1.69. Plus again 0.49. Plus 10.89. And the 22 minus 24.7 squared is 7.29. Plus 23 minus 24.7 squared gives us 2.89. Yeah, you can consolidate these and divide by 9. So if you're doing the right thing, on top, you should be able to find 51.1 when you add all these. But you can counter check the numbers at your own disposal time. Really, you will have 54.1 divided by 9. What do you find? What is 54.1 divided by 9? Find that answer, put it in the square root like that. What do you find? That should be 5 point something or 6 point something, eh? 5. Is it 5 or 6 point something?
It's 6. 6.0, and then there's a recurring 1.
All right.
6 point.
What is the standard deviation then? The square root of that is the standard deviation. What is it? What is the standard deviation?
I'm using the phone, so maybe I don't know. Nelly, do you have a calculator?
I do have a calculator. It's giving me 0.81725224.
I doubt. I do doubt.
Sorry?
I do doubt. The square root of 6.
The square root of 6. 6.011. It's giving me 2.4517340.
Okay, at least that makes sense. So that's that. Let's find the standard deviation. What's this now? The coefficient of variation, the CV, yeah? For Joy. The CV is what? Standard deviation divided by the mean, yeah? Standard deviation 2.45. To be divided, what was the mean? What was the mean for Joyce? Colleagues, we calculated the mean. What was it? You have forgotten.
It was
24.7. Multiply that by 100. So what is the CV? Coefficient of variation? What's the coefficient of variation?
That's 2.5, right?
2.45 divided by 24.7.
Okay, multiplied by 100. That's 9.9190.
9.9?
119.
All right, 9.9%. Okay, that's a CV. So to conclude, the last part of the question says whose performance is consistent. So check the CV. For Joseph, the CV was what? 19%, 20%, right? It was 20%.
Yes.
20%. Then for Joyce, the CV was what? Is the 9%, 9.9, which is approximately 10%. So now the rule is the lower the CV, the coefficient of variation, the more consistent the performance is. Remember, the coefficient of variation measures the variations, like the deviations from the mean, from the average. How were you deviating? Were you maintaining that maybe you're just maintaining almost similar grades? You get what I mean? Maybe last time you get 45, that next time you get 36, then you get 38, then you get 37. You're just revolving around the same numbers. You get what I mean? So
Yes.
that's what CV measures. So since Joyce has the lowest CV, coefficient of variation for that matter, then Joyce's performance is more consistent. That's the conclusion. So Joyce's performance is more consistent for that matter. Okay, any question? We have said Joyce's results are more consistent. Yeah? 5. Question 5. But you're fine with question 4. We go to question number 5. But always fine. You're not responding. Anyway.
Well, I'm okay, sir. I'm on my side.
Okay. Let's proceed. Yeah. Okay, let's proceed. We are told that let the X follow the normal distribution where the mu is 15, that is the mean, and the standard deviation is equal to 10. Then you have to find the probabilities of the normal distribution. Now, I haven't talked about the standard normal distribution. Remember yesterday I touched it a bit. I also mentioned that I haven't started looking at probability distributions. So let's just present the solutions for A. So the probability that X will be less than 20 will be given as follows. All right, you're welcome. The z-score shall be X, which is the X value that we have, less than mu divided by the standard deviation. You have to calculate the z-score. And our X is 20, so you shall say 20 minus 15, which is the mu, divided by the standard deviation of 10. That gives us the z-score of 0.5. 0.5. Now, using the standard normal distribution table, right? If you use the standard normal distribution table, we'll show you how to read it. Table. You write this statement, it's very important, using the standard normal distribution table. Then the probability that z is less than 0.5 is equal to 0.6915. 0.6915, which means the answer that the probability of X less than 20 is equal to 0.6915. That's how the probability is found. So that's the one for A. Yeah, that's the one for A. Using the standard normal probability distribution, you should be very conversant with the probability distributions. Yeah, you will be conversant very soon. Okay.
Sir,
0.2, ma.
you're too fast on question 5. Me haven't gotten anything.
Oh, on
Yes,
question
you're
number
too fast.
5,
Yes, please.
okay. I said on question number 5, this question comes from probability distributions. You get, and when you look at probability distribution, that is almost the fourth or fifth topic in business statistics. So we had agreed that the topics that are still far from us, I can present the solutions, then so that you start typing since time has gone. Then when you start typing, then we'll start now learning slowly, so that people get to understand. As for now, I'm not teaching, I'm presenting the answers. This is not a lecture.
Oh, okay. All
It's
right.
just a
Thank you.
presentation of an answer. Thank you.
All right, sir.
You're welcome. Because when I start teaching, I'll bring the standard normal distribution table, show you how it reads and how we extract these answers. That is when I'm teaching. The B1, the probability that X is greater than 12. This one, again, you have to do the Z-score, which is given by this formula. And our X is 12 minus the standard deviation of 15 divided by 10. This gives us negative 0.3. Negative 0.3. So you are finding the probability that Z is greater than negative 0.3, of which this probability is equal to 1 minus the probability that Z is less than negative 0.3. When you do that, we know that we shall have 1 minus the probability that Z is less than 0.3 is given from the standard normal distribution table as 0.3821, which shall equal what? 0.6179. 0.6179. So therefore, this is it. It is 0.6179. 0. Because it is the probability. 0.6179. All right. 0.6179 is for B. Then final on C, question 5C, you want to find the probability that the Z-score falls within the range of 12 less than X less or, than 20 in this range. Now, to find the probability falling within this range, since we already know the probability that the X is less than 20, this one we found it that it is equal to 0.69115. And we also have the probability that X is less than 12, that this is equal to the probability that Z is less than negative 0.3. That's what we found. We found this to be equal to 0.3821 from the previous, from B. Then if we have this, then it's very easy. The probability that 12 is less than X less than 20 shall equal the probability that X is less than 20 minus the probability that X is less than 12. That is what it is, which is basically 0.61979. What is the probability that X is less than 20? It was A. This was A. We found it as 0.6915.
Yes.
Yeah, 6915. Minus what is the probability that Z is less than 12? He said this is 0.3821. And then when you do your computation, you should be able to find 0.3094 as the probability that the Z-score will be within this range. It is basically 0.3094. 0.3094. So that's that. That's briefly about question number 5. So it is quite easy. You will see that when we expose you to the standard normal distribution tables, to the probability distributions in general. Okay.